Let's go to the Dwarflab app. Go to connect. I named my telescope Dwarfy. Haha. Connecting. Wants to join? Yes, join. All right, and here we go. And the default presentation you get from Dwarflab is the photo application. And if I scroll down, we see that there are some light settings, the ring indicator and the battery indicator. Those are the lights that are on the Dwarflab itself. I'm going to turn those off, because turning those off will help conserve the Dwarflab battery. That's the first thing I'm going to do. The next thing I'm going to do is I'm going to tap on the photo application. And it presents me with the dwarf screen. Now notice we're seeing some stars. In the case of using the Dwarflab for astrophotography, the wide angle view is not used. Telephoto view only is used. So what I'm going to do is disable the wide angle view. And then the next thing I'm going to do is tap the focus button. Whoops, no, I'm not going to tap the focus button. The first thing I'm going to do is go to function, and no, the first thing I'm going to do is go to photo, and I want to change from photo to astro. I want to put the application and Dwarflab into astro mode. Now that I'm in astro mode, now I will go to focus, and I will tap the infinity button. And the Dwarflab is now focusing. Bingo. That's what I call sharp and clear stars. So, next thing to do. We will go to function and we will do a calibration. And I'm going to confirm that I'm seeing stars, and the Dwarflab is now going to calibrate itself, doing something I think the astro folks call plate resolving or plate solving, one of those two terms. Basically explained, or mansplained, if you will, as I understand it, Dwarflab is basically taking pictures of parts of the sky and comparing it with pictures of the sky in its memory, and it's going to use all that information to align itself and now compensate for Earth's rotation so that it can maintain stable positions in the sky. Look at that. There's a meteor or a satellite or a UFO that just went by. So there's a real-time view of the sky, straight up from the dwarf, because I have the cameras pointed straight up. What I'm going to do now is go to the function and go to the atlas. And once I'm at the atlas, I will tap the search button, and I'm going to type C/2025. It shouldn't need to really type anything else. The list I get gives me C2025 A6 Lemmon. That's the comet I'm after. And it finds it in the atlas, and now I tap this little icon over here, the little A button, to have the telescope go there. Tap OK. And now the telescope is going to go find that object in the sky and hopefully present it to us on the screen. According to my iPad, I'm currently pulling 2 bars of LTE out here. That's about as good as it gets. Quite often it'll drop to 1, and that's when the internet really gets unstable. But as long as we maintain 2 bars of LTE, I'll have a good internet connection for my laptop to use. Success. Oh, and there it is. Wow. And the tail's down this time instead of up like it was last night. That's strange. I wonder why that is. Maybe my image is upside down. That's interesting. Well, anyway. All right, so we now have the Dwarflab in Astro mode, tracking C2025 A Lemmon, as you see at the message at the bottom of the screen. You notice the reddish tint to the screen, which is apparently common for unfiltered light. Here we can see some more satellites streaking across the sky. Probably belong to Elon, I suppose. All right, so there are parameters we can adjust before we start taking pictures. And one of those is we can filter out this red, the red that you see across the screen. Now, sometimes it's beneficial to leave that on. In fact, when I shoot videos of this comet, it looks better if I leave this filter on. But I'm going to go ahead and turn it off so you can see what that looks like. I'm going to press the cut, and notice how the red now disappears from the screen. We can still detect a bit of a tail coming off of the comet, it appears. We should be able to make that tail look better by increasing the shutter. Right now, by default, the shutter is at 1 second. So Dwarf opens up its camera by default with a 1 second exposure and a gain of 80. The gain is something we can play with also. For example, right now, just with a 1 second shutter, if I drop the gain to 40... No, there we go. So now we can't see a tail anymore. Notice that the tail kind of disappeared. In fact, the comet really just looks like one of the other stars in the sky. So we'll bring that back up to 80. Oop, there we go, 80. And what I'm going to do is increase the shutter. For pictures, 15 seconds usually works pretty good, and the Dwarflab maxes out at 15, or at least the Dwarflab 2 does. Now, I believe the Dwarflab 3 allows more seconds on the shutter, possibly up to 30. I don't really know, but the Dwarflab 15 will top you out at 15. So notice at 15 how much the screen is now brightened for us, and we do see a tail. So what I can do now, since the screen did get quite bright, is I can, with a shutter of 15, I can maybe reduce the gain. Let's drop the gain to 40 and see what happens. Now, we'll have to wait longer to see this change on the screen because of the fact that we have the shutter open at 15 seconds. So you have to wait for at least 15 seconds to go by before the camera is going to update and present us with a new image. So let's be patient. We'll wait for that to happen. Ah, there we go. So a gain of 40 doesn't look too bad. We got some tail. Got some fairly dark sky behind the comet. The head or coma of the comet is clearly visible. Ah, what an amazing camera. Be aware that this Dwarflab, as cool of a telescope as it does seem, it really is very low in magnification. I mean, you don't really get a whole lot of in fact, you get really no control at all over the zoom or the magnification on it on the telephoto. The telephoto lens on the Dwarflab is kind of equivalent to, don't quote me on this, but think of it as similar to if you were looking through a pair of powerful binoculars. Is pretty much the magnification that you're getting. Now, for things like comets and things like deep sky objects, that's all you need. That's plenty. The key really then is just to have it on a star tracking mount to help compensate for Earth's rotation. With comets, you have the additional problem too, the fact that they are moving also. They are not stable objects in the sky. So you can't just take hundreds of pictures of them and stack them. The comet is moving as well as the Earth. I suppose there are some systems that can compensate for that, but I don't think the Dwarflab can do that very well. But what the Dwarflab can do is stack 2 or 3 of these 15-second exposures and really give you a nice picture of the comet. So I'll show you how that's done. Once you've got your settings set and you're satisfied with what you're seeing, and I do like that view of the comet right now, I'm just going to tap the red button, and it's going to start taking the pictures. And if you look at the bottom of the screen there, it shows you that my shutter's set for 15 seconds, the gain of 40. Total $9.99. All that means is if I don't stop this process, it'll take 999 of these pictures and then shut off. I'm going to take about 4 of them. It has taken 1. It hasn't stacked any yet. Now it has stacked 1. So it's showing us what 1 frame looks like. It has taken 2 pictures. It's still showing us the 1 stacked. Three pictures. Four. And I think maybe I'll let it go a couple more because anytime you have those meteor streaks flying through a frame, that does affect the image processing software. Those frames will be rejected. So let's get some more frames. Oh man, there's so many of them. I gotta get some video of this. Alright, so we got 6. Yeah, see, it says stacked 1. It's taken 6 pictures, but it's only stacked 1. The reason for that is it's rejecting those pictures that it's getting with meteor streaks in them. So that's just crazy. Now it's showing us stacked 2. That's still not a bad picture. What I'm going to do is take 8 pictures. In post-processing, I mean, the Dwarflab will do its own internal processing and sometimes give you really good pictures, but there's also third-party software you can use to run these pictures through and process them. And so, in addition to what the Dwarf gives me, I'll also take these home and see if I can make some better pictures out of them myself. But currently, that's looking pretty good. I'm going to stop this process by pressing and holding. Long press to stop. And I will stop the process of having the Dwarflab take pictures at the current settings. If I were to be taking a picture of a deep sky object, let's say, for example, I was shooting the Andromeda Galaxy. In that particular case, I would let that process run and let those... I would go for 100 pictures at least, preferably 200. I would try to get about 200 pictures of a deep sky object like that before I would stop the process. But in the case of a comet, you don't need 200 images of it. You only need a few to be able to stack them and get a good picture. Anyway, here we can see what our final picture looks like, and once I run that through some imaging processing software, that'll look even nicer. I will end the current session. What I'm going to do now is shoot some video. So we are still tracking the comet. I'm going to change from astro to video. And I got to say, the 1 second exposure videos do look kind of cool, especially when the satellites roll through. You don't get a whole lot of a tail, but you do get a lot of variation on the tail itself, as it seems to. You can kind of detect some movement in it. I'm going to shoot some video of this at 1 second, and then in fact, I'm going to leave the red on too. I think the red looks good. Let me do anything else with this. Now notice I have some more options when I'm dealing with video than I had in Astro. So I could turn on that red filter, but I'm going to let that pass for now. I'm going to leave the shutter at 1. The gain of 80. I'm afraid if I drop that gain, I'm going to lose that tail. But let me drop it a little bit. What happens if I drop it to 60? Oh, wow. Okay, then. And then what happens if I run the shutter up to 5? Getting more tail, better coma. So brighten up the picture a little bit, but it's to be expected. Drop the gain to 50. Not bad. Take that shutter down to 4. Let's record some of that. That don't look too bad. So I should just press, if I just press the red button, it's going to start recording video. Of course, it's not really recording video in the sense of live video. It's recording video in the sense of frames. Because I have the shutter set at 4 seconds. With the video that the video that is being created is a series of 4-second shots. Anyway, hope that made sense. But so anyway, I'm going to let this run for, you can see the counter up there at the top. We're at, what, 40 seconds? Yeah, let this run for maybe a couple of minutes. And then we'll go back and take some more pictures. And you know, normally I'd be playing some music while doing this, but since it's likely that I might put some of this video on YouTube, no music. Holy Christ. Let's go ahead and stop this video at this point.